So hope you had a nice break. So myself, I'm Subhash Chandra. I'm here to present this K8 is like unleash the power of Istio. I'm not really going to too deep, but I'll try to tweak it based on how much you're aware, like how much working knowledge you might already have it. Based on that, I'll try to tweak the presentation. I also have a quick short demo as well. And this is the first time I'm presenting, at least on CNCF Hyderabad community. I used to sit on the other side, and with the support and motivation from Atul, I suddenly decided that okay, we have short of speakers, and I have a long-term plan to come and just present something here. So the timing was perfect, and I thought like, okay, let me just make it this time. Okay, that's how I just started this. Brief introduction about myself. I'm working as principal cloud architect at Oracle, and I'm also like, if you actually ask me my technical journey, it's been long. I kind of was almost close to 2 decades. I started working something on mainframes, IBM mainframes, DB2, COBOL. I used to start, that is how my career started. So later I switched to Java, and most of my career I've been working as kind of full stack developer, Java, J2E, and website and things. And my cloud native journey is something which started just very short, around 3 years back. And I found it interesting, and even better late than never, I just tried to make a big switch, kind of completely from pure hardcore developer who used to always sit in the back, who never sees any customer, and suddenly customer facing role. It's been a big transition, and I just quite enjoyed the journey as well. And in that transition, I started clearing some certifications. I hold this Kubesnot, the hard one in the market. Like I just cleared all the relevant certifications. I hold that. Similarly, cloud has been my primary thing. I had multiple Oracle Cloud certifications as well. In the free time, yeah, my things are like typical thing, reading and blogging. I should have put a star over there because I'm not doing it actively, at least for the last few years, because of different reasons. But I generally used to write some Telugu poetry as well. I used to maintain a blog as well. That's on the personal side. And yeah, you can connect me with on LinkedIn as shown over there. So before I go there, right, how many of you just, like in case of, already Atul asked, forgive me, I'm trying to make you do it again. How many already have you are aware of or like have a proper working knowledge of Istio? Okay, that's quite a good number still. So I guessed it. Obviously, I thought like even it will be more. The number of people who worked on Istio would be even more than that. But nevertheless, I'll try to keep it with a short overview, and also I'll try to keep a like some kind of like one short demo on a specific use case which I worked on. Right. So first of all, why do we need something like Istio, right? We'll try to see the use cases which demand for really having that kind of solution, right? This is a typical service mesh. Let's say this is not technically accurate diagram, but just try to bear with me. I'm just trying to give a simple use case, right? Let's say you have a Kubernetes. Just the rectangle, green color rectangle box, you assume that as a Kubernetes cluster. Obviously, I'm not depicting the worker nodes and other things. Don't get into the technical details, but I'm trying to more drive towards the use case, right? So let's say you already have deployed some services over there which are running. The primary use case, what do you exactly need, right? One service need to talk to the other. That's my primary requirement, right? You will definitely have a bunch of services which will be deployed in a cluster. So very primary requirement is okay, my service need to talk to the other service. Similarly, the next thing if you take like my service sometimes may need to talk to external service as well, right? And again, obviously you deploy multiple things and you're not going to keep them just standalone. Obviously external world needs to access your application. So then there will be a load balancer that comes and sits in front of your entire cluster, which serves the traffic to the public, and the end users will be connecting that, right? So this is one of the things, right? Like if you see here, the service to service communication itself may not be so simple, right? Sometimes you may think that, okay, now I have a need, I need to do something like, I need to make sure that the service, even though if it is enter one service to other service, I need to make sure that it is secure. I need to communicate maybe over a TLS, even though if it is internal, probably for some variety of reason you want to do that, right? And probably, let's say if you're trying to do it external service also, that external service may need some TLS kind of thing, and you may need to make sure that the relevant certificates and everything are maintained and properly, the TLS connection establishment and everything is proper. Similarly, when your load balancer is trying to come to your cluster to access any particular functional services, there may be a need that, okay, you may want to again redirect the traffic, the typical ingress related things, right? Like some of the functionality will be served by service 1 and some of the functionality will be served by service 2, and maybe you need to have a routing logic, maybe based on the path or some header, and you will try to do some kind of logic, right? So there are a lot of things happens over there, especially when it is service to service, right? You really don't want to make your service aware of these external things, especially if it is over the TLS, the communication, other things. You don't want to really embed that kind of logic into your service code. You never do that. That's not definitely an ideal pattern. So what you try to do is you just try to offload that. Like let there be an agent, because these are all generic requirements, and I better have some tool which can really do the job for me, right? That is when the service mesh kind of solution comes into picture. Right? And Istio is one of the popular and enterprise ready. It's been well tested. CNCF graduated project. It's been in the industry for a long time. And here we are going to see a quick overview about that. And something similar to Istio, we also have a Linked. That's also another service mesh solution, which again, it's also popular in its own way, but depending on the use case, you might want to choose one versus other. Right? So that's a basic background. Why do we really need to have such a solution? So what is Istio? So like just a standard definition from their documentation itself says that it's a service network layer that automates networking and communication between microservices, especially purely from networking. How do you really one service talk to other and other things? But that's one of the very specific features. Istio really comes with a bunch of additional things as well, and which you will really try to use based on your use case. And just in a previous first session, if I'm not wrong, there was a question around that authorization policies, right? Something about that specific side. And the answer was like, obviously, you for that purpose alone, you don't really need to load your system with Istio, because it again depends, right? Like if you are leveraging most of the features, you better to have it, because Istio really comes with a bunch of like too many features to do that, right? This is a very high level architecture diagram, how exactly it works. If you see service A and service B, and we have, okay, let's basically talk about the high level components, right? We have something called control plane, something similar to Kubernetes. We do have two kind of high level components, one is control plane and one is data plane, right? Control plane is the one which actually has centralized logic to entirely orchestrate this kind of Istio, how exactly it should work, right? And data plane is nothing but, again, there are some agents which will actually go and sit in your each of the pod and try to do that. If you see this in the bottom, there are two variants I mentioned. Right? There is something like sidecar mesh, which has been very popular and it's still the widely used, most of the enterprise applications still using that. And there is a recent addition to that is called ambient mesh, right? So why, I'll just again quickly go give an overview about that, right? If you see the sidecar mesh, which is actually depicted in this architecture, you see for every service related pod, there is some small blue box you see, right? There's a proxy. How does it happen? When you really install Istio in one environment and you try to do some kind of injection, right? What happens is Istio tries to inject one container into each of your pod, wherever there is a namespace injection happens, right? So this container's main purpose is this has a logic. It knows how to interact with IstioD and take care of other functionalities based on your configuration that you enable the MTLS. It knows how to reach other services, and all this logic is embedded into this proxy. And your service as such or your pod, you really need not bother about these things. So Istio is already like making sure that it's automatically happening once you set up the Istio and enable the sidecar. It just sits in that, right? And that is what is taking care of the communication. So this service A to the proxy, and proxy will take care of the actual communication between two different services and any other additional things based on your configurations, right? That's how it's going to work. And IstioD is the centralized orchestration control plane, which sits and monitors all your the proxies and everything, right, across your cluster. So what happens, the main difference, if you see why there was a need to introduce something additional, which you already have a working model, why there is a need to go to some new variant called ambient mesh. The primary reason is, if you see the proxy, which is also popularly known as sidecar pattern, it basically injects a container into every of your pod, right? It's automatically what happens is, like if you have more number of pods running in your cluster, it is automatically eating up some resource anyway. However minimal they are really going to exponentially grow based on the number of nodes, number of pods, and the overall cluster size, right? Which is kind of having some impact. The second drawback, or like you can say limitation, is that let's say whenever there is an upgrade, like they injected some kind of new functionality, proxy related functionality, right? It's not easy to, like, while the cluster is running, you can't really, without restarting, you can't really go and try to do that, right? Because it's sitting everywhere in every of the pods, right? So that's another thing, right? So these kind of limitations they thought, and let's try to have a different version. That is why they came up with ambient mesh. And I'm not really covering that ambient mesh. It's a bit really too deep architecture kind of thing, but to keep it high level, it's not really going to follow the sidecar pattern. It itself has like its own separately, like it'll run as like its own deployment will be there. It'll sitting in one namespace, and it has its own deployment. It's not really going to have a kind of, for every pod there's going to be proxy kind of thing, and it works. I mean, again, it supports L4, L7, and some of the things are like it was recently GA'd around 6 months back. Earlier it was in like LA, and now it is GA'd. But even then, probably there are some limitations. Especially, it may not be really suitable for very enterprise large scale applications. But however, you can still try it for any of the single cluster based things. You can still use it, right? So if you see the high level use cases, so these are mainly the two variants, and the high level, again, I just kept only the few, but if you go to the documentation, you can find very different type of use cases and the features for the Istio, right? So one of the key things, traffic management, and this is also going to be one of the focus for this session, where I have a demo which is based on this traffic management use case. Again, traffic management is like everything it takes care of, ingress, egress, and all this like routing and different things are there and the subcategories. Similarly, security comes with this kind of automated certificate management. When you really want to enable the MTLS, one service need to communicate to the other service over a TLS. Those kind of things are all automatically provided using this security thing, right? Observability, again, it's a broad topic, but the thing is, when this service to service communication happening, even Istio enables kind of some additional metrics which will be definitely useful, which will give you some patterns across exactly one service to other service, how the communication is happening, or any kind of errors, success rate, or rate count, and most of the things, right? These are automatically, these metrics are available and exported for you, and you can again build any of the observability tools to really make use of that, whatever that Istio is offering for you in the observability area. Similarly, extensibility, again, this has something called WASM, WebAssembly language, right? That kind of plugins you can really write it if you are really to that deep and you have some requirement, though you have Istio is really providing you a wide variety set of features, still you have a need to customize that, then that is a way to really, Istio is still giving away where you can really provide that kind of plugin and just put it into your Istio so that you can get your required functionality. Multi-cloud or multi-cluster is again another interesting use case where exactly like how does it happen is, let's say you have two different clusters, right? And if you see typically these two different clusters are completely unaware of each other, right? Let's say now if I want to talk to a service which is running on the other cluster, the only way is like either you have to externally expose it through a load balancer, you will call it, right? But let's say I want to really make my services completely agnostic, they don't really care, right? I just need to call another service, and that service can be running in my own cluster or can be running in another cluster also, right? Istio really comes with a nice solution there. Like, if you really have a multi-cluster service mesh installed, where Istio is actually trying to coordinate that thing, and that service discovery is automatically taken care of by Istio. So service one can talk to service 2, irrespective of whether the service 2 is part of my own cluster or a different cluster. Okay, that comes with a bunch of installation steps and a configuration, but the point is, it is really giving you that kind of flexibility. That's also one of the key features or use cases for Istio, and it is giving you that, right? So these are some high level things. I am not really going to too deep into, like each one itself is takes its own separate session if you really want to go deep into that. That's how feature rich that Istio is. So especially I am going to focus a bit on traffic management along with a quick demo. So if you take traffic management, again there are sub areas, right? Ingress, and if you take ingress itself, Istio comes with some components called gateways and then the TLS termination. And recently, if you are closely following all this K8s latest updates, K8s traditionally we used to live with something called ingress, right? And K8s itself came with the recent version, they came with something called gateway API, right? And obviously Istio is one of the implementation for that gateway spec, and it really comes with a stable implementation of that gateway spec as well. TLS termination, as I mentioned, again, you can like either whether it's at the load balancer level termination or the MTLS between service to service, all those things are automatically provided for you. Egress, something similar, again you have egress gateways, and egress gateway is one of the ways like it will try to manage this multi-cluster approach also. It could be one thing which will get used, and external service access and TLS origination itself, right? Like say exactly, like, so you really want to manage the certificates, like when actually the service is trying to make a TLS call, this automatically the certificate management related Istio itself has one dedicated component which takes care of the certificate. If you take actually closely look into the Istio components, it has like a bunch of components, each takes care of one particular functionality, whether it's a service discovery or certificate management or some extensions. And there is an interesting history as well, right? In fact, Istio had something called all these things are like separately running as a different services in the very beginning, and later they combined everything and called a single binary, which is the Istio D. We call it. What is the control plane I depicted in my earlier slide? That is popularly known as Istio D, Istio daemon, they'll call it, right? Earlier it used to be like actually a multiple set of services. Later they combined it and made a single binary out of it. Basically, it just has however, like it has internally, like it has a separate component for each of these functionalities. Request routing, again, as I mentioned, ingress functionalities, right? Ingress, typically you have multiple options. Obviously, Istio, as it's a kind of a superior solution, which is kind of trying to bundle most of the features together in a single place. But if you take ingress alone as a requirement, there are multiple other things which are provided. You have NGNX and traffic and other things are there. Similarly, those kind of things are already built into Istio. And there are some people like who generally use only the ingress part of also Istio. But Istio really strictly not meant for that, but you can nevertheless do the same thing, right? Request routing, that is what. Traffic shifting, again, if you simply know the popular testing technique called canary testing, A by B testing you call it, right? Like one service you are trying to introduce a new feature and you want to see how it works, only 20% of the traffic I'd like to shift to a new service and 80% will be handled by the old service. You test the stability and once everything is fine, you slowly increase the thing and finally you get rid of the old service. This kind of popular technique, right? It will be easy to implement with Istio in the microservice-based architecture, right? That's what the traffic shifting. Circuit breaking, again, you know that based on, there are some configurations based on, let's say you really want to control the number of operations or like number of requests which are going in based on some configuration. Only I can really serve only these many number of requests. Later I just want to put a stop to that, right? Those kind of configurations you can do internally at the like your Kubernetes service layer. That is what the circuit breaking means, right? So these are some of the typical traffic management features we have in Istio, and this is I'll just switch to the demo, which is again one interesting use case in the traffic management related, right? So the demo is going to be mainly on the traffic handling, okay, right? My use case is something like I have two different services installed in my cluster. One is a plain HTTP based service which takes my JSON payload, gives some response back, and then there is a gRPC based service, right? gRPC, hope you, I mean, how many of you are aware of gRPC? Okay, wonderful. So gRPC, okay, just to give some context around it, you know HTTP and HTTP2. The recent addition to the protocol stack is HTTP2, which is quite faster and gives you some additional capabilities like traffic multiplexing, multiple requests, multiple responses, and streaming and other kind of things, right? So what Google came up with is Google kind of came up with something called gRPC, remote procedure calls, which underlying actually takes leverages the HTTP2, right? And this is popularly used, like at least most of the enterprise applications based on again based on the requirements. But let's say there is a need for my application to host. There are like one HTTP based service and one gRPC based service. Both are sitting in the same cluster, and now I have a load balancer which is exposing. And some of the applications, some of the front ending applications probably directly accessed by the user over a browser, and some additional application which is trying to reach that gRPC based service through some kind of tool or something. It could be, right? I'm trying to do what I'm trying to do is I'm just trying to expose both of the things through a single load balancer. Obviously, some of the CSPs, if you see, the load balancer itself has a capability to specify what should be your backend protocol, right? Obviously, it should be HTTP2. It should support HTTP2. Then only you will be able to communicate with the gRPC based backend service. If not, it will not work, right? So some of the CSPs has built into that, but again, that works. Let's say if you have a HTTP layer 7 load balancer, for example, you have for some reasons you say you are trying to do it with a NLB layer 4 load balancer, and you want to really offload these things to the next layer, which is like it ingress or like whatever it could be, right? So if that is the case, like Istio has a capability, it has some automatic traffic detection capability. So it will enable so you want to enable the TLS termination at the Istio. At the same time, you will be able to interact with both these services simultaneously, depending on whatever the protocol it is. Istio, either you can explicitly mention your protocol, but Istio also has a capability to automatically detect based on, till that layer it is a TCP kind of thing, like it's a pass-through, right? From my load balancer till my Istio level, it's going to be kind of simply pass-through, TCP traffic it is. And once it actually enters the Istio layer, there it has a capability, okay, this is something like HTTP meant, okay, this is the HTTP2. So this has a capability to handle any kind of traffic, right? And now again have a setup, I'll try to set up in such a way that I'll try to have different routing rules. One is, if you can see clearly, but anyway, the top one actually is for gRPC one and the bottom one is a NGINX, which is a HTTP based one, right? I have a request rule set up for that. So automatically based on what I'm trying to invoke, it will go and call the respective service, right? That's what the typical use case. I try to do it with a Istio based Istio ingress controller. And interestingly, obviously, if you see, in this use case, I'm only leveraging the ingress part of Istio. It really doesn't require anything sidecar related. Again, it's optional thing, right? Istio comes with bunch of things. What to use, again, depends on your case. And if only for that particular purpose, whether you want to use Istio also, it's again a call you can make, right? Because Istio is a bit complex to set up and it has its own pros and cons. You need to carefully evaluate and do that. But this is one use case which I try to do using Istio. Okay, let's not go there. I'll just try to quickly switch to the demo. Any questions so far, or are we good to go ahead with the demo, so that you can understand? Like, I hope you're clear with the basics of what exactly I'm trying to cover in the demo.
Subhash, does it have the ability of HTTP to HTTP redirection also?
You mean Istio? I guess you should be able to set it up somewhere in the Ingress tools. We should be able to have the redirection tools as well.
Front-end config, so there was one CRD,
Mm-hmm.
which is front-end config. So we actually configure on that layer in GK.
Okay. I'm sure that Nginx anyway has a capability, but at least Istio I have never tried that redirection capability. It should be there, but I hope so. I haven't tried it. So. Again, I have this for this demo. What I did is okay. I'm not. This is not visible, right? Why? I need to exit. How it should work?
Sharing the screen, entire screen.
I hope so. That's how it looked like. Let me stop and reshare it again.
It is still stuck. Have you extended it, the monitor, or is it mirror?
I think it was mirroring.
It's not mirroring right now.
Should I?
This you can forget, just check this, or you want me to just
Shall I stop sharing?
it is still showing screen two.
Screen one.
No, not this. We have to change something here. Yeah.
Change. Window wrap. Extended display. It's okay. We can keep
Just
it.
increase the font
Yeah,
size.
yeah, sure. Is it visible, this font? Okay. So for this demo, as I was explaining in this last diagram, right, what I tried to do was I set up a simple Kubernetes cluster with 2 nodes, and that is an Oracle cloud. Obviously, that is where I'm trying to do that, right? So there, I just tried to set up this, and I have enabled, again, Istio, either you can just install with a plain deployment model where you can just grab the full YAML and just apply in your cluster, or you can also do the Helm chart. And there are some of the CSPs which will try to make your job even more easier. They'll have some kind of configurations on the front end itself. While trying to create the cluster, it will ask you what kind of add-ons you want to set up in your cluster. So that's something which is available in Oracle Cloud also. We just set it up that, and it automatically install Istio in this cluster. If you see, so these are 2 nodes available in this. And I have Istio already. So Istio ingress controller has been already set up. If you see this Istio ingress gateway, you can't call, I mean, you basically call it as ingress gateway, and that is a type of load balancer which is provisioned in the Oracle Cloud, and it has a public IP. So what I tried to do is, again, I just wanted to do it over the HTTPS termination, that kind of approach I wanted to choose, but for now I just went with the self-signed certificates. I already generated the self-signed certificates, and I just try to map this IP address to a particular domain, and I just try to map it in my etc host file. So that's the setup I used, and I'm just trying to, I have two different services, right? One is Nginx, just like plain Nginx. You can just simply run Nginx, what you call like that Nginx homepage you get, that is HTTP based service. The other one is gRPC, which I try to have a protocol. Where gRPC, like you have a bunch of examples available in their official website itself. I have a Python based gRPC app, which just simply gives a hello world kind of thing. But it has a, again, gRPC works with something called protobuf. That's another important concept to understand the gRPC, which has a spec. I'll just show you in a while. So this is one of the GitHub repository where I maintain this code, and if you see this, there is something called, just to understand this, how exactly it works. You see this, this is what the protobuf service definition looks like. It's just like hello world. It just typically looks like a simple programming language, either Python or Java, right? There are some kind of statements and the top starts with, and then there is a service. This is actually the service, which is the skeleton, you can say, right? What kind of methods it's exposing, and in the bottom you see the hello request, that the default things, right? The default values, right? And I'm trying to give you in the request, in the gRPC request, what I'm going to make is I'm just trying to parse this name, and it is going to construct a message, hello so and so name from so and so pod name. So that's a simple logic I put into that corresponding Python pod, which is actually running in this class, right? That is one service. That is a gRPC based service. The other one is a Nginx, plain Nginx based service, right? And next thing is, and these are the Kubernetes related YAML files I have for this demo. And if you see hello world and gRPC, the ones with gRPC prefix are that first gRPC based service, and HTTP is nothing but your Nginx service. So I have the deployment, I have the service. Similarly, if you see there's something called virtual service, that these virtual services is actually the key thing, which is really making the other like Istio specific functionalities to work in a way, right? Virtual service is a Istio specific configuration. Right? And I'll just try to open one of the thing, and so that you'll understand what exactly is happening there. Again, I'm not trying to do the setup here. I am just trying to walk you through the setup, and finally I'll show you when I access like what's happening. That's the quick demo about it, right? If you see the host, I already gave this grpc-https.istioexample.com. Obviously, this is not a registered domain. It's just like I just mapped it. I gave a self-signed certificate along against this domain, and I just mapped those certificates to this particular secrets, right? So if you see that secrets, I'm going to come to like shortly. But the way it works is, if you are trying to use this host name and then slash nginx, this virtual service will come into picture, and it tries to see there is a URI prefix. The slash nginx should really map to my nginx service. Similarly, there is something called slash grpc kind of thing, and that will really go on. We have the other thing, right? That will have the similar counterpart for this. You see the same thing, just a counterpart to the above one, and it just has something like slash greeter say hello, right? That is where that hello, the say hello message has been exposed behind that gRPC service. So these are my two virtual service definitions, and I'll just show you one more thing which is actually important for understanding this logic. That is my gateway definition. So this is the gateway definition. This actually really has that. So there is a Istio ingress. I mean, if you see the Istio system, there is a Istio ingress related pod is already running. And now a gateway definition directly binds to that using a selector. If you see this selector Istio ingress gateway, this is the same thing that will be there in my Istio ingress gateway pod, which is actually running the Istio system namespace. So that when the traffic lands there, it knows, okay, this is a gateway which is actually really required to, I mean, this is where the first traffic lands. And here is a main logic that is happening. You have what is a port for your, that is again Istio specific thing, and the TLS mode is Fimple and credential name, right? This credential is nothing but your Kubernetes secret, and which is holding your certificate. That in your case, it is a self-signed certificate. So it is mapped here. So effectively what's happening is the TLS, when the request comes, actually when it lands here, the TLS is getting terminated here. From here, whatever the traffic that goes back to the service, that is from this particular like ingress to the backend services, it's a plain thing, right? I mean, again, HTTP plain in the sense HTTP or HTTP2, like it will try to make sure that. But the TLS termination as such, it's trying to handle it here itself by using the secret I configured here, right? So that's the overall setup. I have these components. Now I'll just try to show you what will happen. Let me, instead of typing it, okay. So this is how I'm trying to, I think I just need to, you see that it is basically saying that welcome to Nginx. This, if you see the curl I invoked, it is passing that CA cert also, because that's HTTPS request. I have a certificate maintained in the same folder, which is actually giving that Istio CA cert, and then I'm just trying to just simply curl, right? It's a plain HTTP thing. So that's trying to give me the corresponding response from the Nginx service. Similarly, and again, gRPC is something which you can't directly, like you would need to have separate, like curl will not work. There is something called gRP curl. There's a separate utility to invoke gRPC based services, and you can't even directly access them in the browser also. Like there is a separate tool you need to have it to enable that web kind of gRPC. So for that, I have, this is the one. So gRP curl, and again, if you see this, what it is saying, actually it's giving me a message, hello Jack from gRPC pod. It is printing the pod name, and also it is actually embedding that name inside the message. That Jack is actually passed as one of the inputs there. And similarly, because it's not simple as a curl, right? I mean, apart from the CA set anyway, which is required to make sure my HTTPS communication is working, there's additional parameter, import path, protobufs, and then the proto hello world. To understand this, right, like I already show you how exactly hello world, the protobufs work, right? That is anyway one of the prerequisites for any of the gRPC communication. So even your gRP call expects that, okay, how exactly I need to invoke this call, where exactly the protobuf path is also important thing, the skeleton file, right, whatever we define. And then the parameters, and then finally the call. The call again is a host name, a domain name, and the port where exactly that it actually is. In our case, it's the HTTPS, so how to do that 443, and then the prefix, the path, greeter / say hello, and it is giving me the message like how exactly, I mean, it's again going to hit the gRPC based backend in the Kubernetes service and actually giving me the response. So that's pretty much, that's a simple demo which involves mainly leveraging the Istio ingress based functionality, right? Again, as I mentioned, each Istio has like a lot of other use cases. Probably sometime again based on the theme of the thing, I'll try to come up with one more topic. That's from the demo point of view. Let me just quickly switch back to the thing, whether it works. Again, I need to choose.
You're done with your testing, right?
Yeah, this one. Yeah, what to explore, just like again, Istio documentation is pretty well formed and it has a lot of use cases and examples neatly explained. If just like do it yourself kind of thing, just you have a Kubernetes cluster, you can just start exploring most of the features because they have a very well documented examples. The famous one known as Bookinfo example, they have some bookstore kind of thing, and which will explain different use cases like how do you do the traffic shifting and all this A by B testing and all those things are there, right? And you also have some interesting things on Linux Foundation training. Some of the things are free of cost, like you can just go and do that Istio essentials, like there are some courses which are free of cost as well. And there is a separate certification as well, Istio Certified Associate. It's also one of the Linux Foundation based external certification, which is part of the Golden CubeStandard program. So Golden CubeStandard is another one, which kind of bunches, almost 13 or 14 our certifications, and it's one of them, right? That's how it is. So that's pretty much I have for this session today. Thanks everyone, thanks for your time. If you have any questions, I'll take up, or you can connect with me later also. You can connect with me on LinkedIn there, okay? Thanks, thank you everyone.